Hi guys, I just wanted to go through this quick example problem with you about diamonds, right? Like this is a cool diamond ring that was designed by Joni E. Ivy, maybe, and Mark Newson. And basically the whole entire ring right here is made out of diamonds, lab grown, which is super cool. And so as you guys know, diamond is actually carbon atoms that are pushed together and structurally like really, really strong based on their covalent bonds. And so I wanted to go through this problem and figure out how many carbon atoms are in these diamonds, right? And so our question is, how many carbon atoms are there in a 1.3 carat diamond? And a little bit of information is diamond is actually 100% carbon. So all of that carbon, especially in a lab-made diamond, is all carbon. And 1 carat, so it's a weight, is equal to 0.20 grams. And so let's go ahead and get started with this problem. So I've just written the problem at the top, and we want to know how many carbon atoms are in 1.3 carat diamond, right? So the way I lay these out is I always start with what information I know, and then sort of build my plan from there. So I know that I have 1.3 carat diamond, those beautiful rings. I've never gotten a diamond ring. That's a different story, right? Anyway, and so we kind of need to develop a plan, figure out that plan. And the question we want to answer is how many carbon atoms are in that diamond? So how many atoms of carbon? Okay, and we can sort of like start gathering information and figuring out what we need to know. So right away, I see that my problem says 1 carat equals 0.2 grams. And so in my plan, I've got carats here. And if I go down, I know that I can get 2 grams of diamond. Okay, and so 1 carat is going to equal 0.20 grams. So I'm going to use that conversion in order to get to grams of diamond. This next part of the sentence tells me how diamonds and carbon are related. So I know that I can get from diamonds to grams of carbon based on that relationship. And if this is 100% of carbon is diamond, that means 100 grams of carbon equals 100 grams of diamond. And so I can use that as another conversion to get from grams of diamond to grams of carbon. Okay, now the next one is we need to get from grams to atoms somehow. And the best way that we can do that is go into this unit called moles. And we can do that conversion based on the number that we find in the periodic table, right? So the number of carbons is 0.1 AMU, right? We find that number in on the periodic table for carbon. And we can replace this AMU with grams per mole. So 12.01 grams for 1 mole. Okay, and then we use what unit we're given. And because this is all about carbon, or I'm sorry, what label we're given. And so 12.01 grams of carbon equals 1 mole of carbon. And so we're going to use this ratio for that conversion. And the last thing is we're going to go from moles to atoms. And whenever we do that, we're going to use Avogadro's number. Okay, Avogadro's number is good for anytime you have moles to go to atoms or molecules or whatever like number of particles that you're looking for. So now I've laid out my plan from carats of diamond to grams of diamond to grams of carbon to moles of carbon, and then finally to get to our answers of grams of carbon. Now remember when we lay this out, every single time we've got an arrow with a unit, it's going to be a conversion. Okay, and every time we use that conversion, it's going to give us the next answer in our chain. Okay, so we're gonna have 1, 2, 3, 4 conversions done in the problem, okay, in order to get from carats of diamond to grams of carbon. Okay, so we've got our plan laid out. So let's see. Hopefully I can write out this whole entire thing on one line, but we'll see. Let me get my piece of paper out. Okay, so we're going to start with 1.3 carat of diamond. We've got 1.3 carat of diamond. Okay, we're going to use that conversion for the first line. And because we have carats on top, we're going to put carats on the bottom. So 1 carat of diamond equals 0.20 grams of diamond. And remember, for these, you want your number, your unit, and your label on every single part. So carats and diamonds are going to cancel with carats and diamonds for this, and we're left with grams of diamond up here. And we move on to the second arrow in our plan, and we've got grams of diamond at the top, so we're going to put grams of diamond at the bottom. So we have 100 grams of diamond equals 100 grams of carbon at the top. So gram cancels with grams, and diamond cancels with diamond, and I'm left with a number that's grams of carbon. All of the other units, everything is canceled. Our next step, right, is where we go from grams to moles. So I've got grams at the top, so I'm going to put my grams at the bottom and my moles at the top. So grams are going to cancel with grams, and carbon is going to cancel with carbon. Okay, and now I'm on the very last step, our last arrow that we had. We're left with moles of carbon at the top. We have 1 mole of carbon at the bottom equals Avogadro's number, which is 6.022 times 10 to the 23 atoms of carbon. And here moles cancel with moles, carbon cancels with carbon. So if I go across this whole entire top part, I'm going to multiply all of my numbers across, right? And every single unit and label in this whole string has canceled with something on the bottom. And so I'm left with a label of atoms of carbon. And I'm going to divide by all of the numbers on the bottom. And I get a number that my calculator gives me, 1.3036802 times 10 to the 22 atoms of carbon, right? So the only unit and label that's left is the atoms of carbon, and I get this huge calculator number. The last thing I need to do is go back and double check for significant figures. Okay, and up here we've got, this number has 2 sig figs. This number right here is a definition of grams to carat, so we don't use that for significant figures. Okay, this seems like a definition to me, so no significant figures. This we pulled straight off the periodic table, so it can have 4, but usually I don't worry about that for significant figures. And same thing here. If I take and use less digits, so if I use 12 or just 6 times 10 to the 23 on these ones, then I would limit for significant figures. But these numbers both have 4 as I have them written, so I'm not going to worry about any of those. So my answer, my final answer, because I'm multiplying and dividing, should have 2 significant figures. I'm going to take this and write this in 2 significant figures. 1.3 times 10 to the 22 atoms of carbon. So my answer, right, I've checked my significant figures. Okay, I've checked, there's a lot of atoms, which makes sense because atoms are really small. And then I've got a label of carbon, that's check, and I've got my unit of atoms. Okay, so my number 1.3 times 10 to the minus or times 10 to the 22 atoms, a lot of atoms of carbon in that beautiful ring. So hopefully that helps you with that problem. If you have any questions, leave comments or just let me know.